Imagine a time before time existed, a time before stars, planets, or even atoms. This was the moment of the Big Bang, the birth of our universe. About 13.8 billion years ago, everything we know burst forth from a point smaller than an atom. The Big Bang wasn't an explosion in space, but rather the expansion of space itself. Imagine a tiny balloon suddenly inflating, growing larger and larger. That's what happened to our universe. As it expanded, it also cooled down, much like how steam cools and condenses into water. This rapid expansion and cooling set the stage for everything that would follow. It's hard to grasp the sheer scale and power of the Big Bang, but its echo still resonates throughout the universe today. It's a story written in the stars, galaxies, and even within our very own atoms. In the first few minutes after the Big Bang, the universe was incredibly hot and dense, a seething cauldron of energy. As the universe cooled, this energy began to transform into matter. The first elements to form were the simplest and lightest, hydrogen and helium. Imagine a vast cosmic fog of these two elements, swirling and churning in the expanding universe. Hydrogen, with just one proton and one electron, and helium, with two protons and two electrons, became the building blocks for everything else in the cosmos. These early atoms were like tiny seeds scattered across a giant field. They would eventually clump together under the force of gravity, forming the first stars and galaxies. But before that could happen, the universe had to go through a period of darkness. For hundreds of thousands of years after the Big Bang, the universe was a dark and opaque place, shrouded in mystery and impenetrable to light. The cosmos was filled with a dense, hot soup of particles, and photons, the particles of light, were trapped, unable to travel far before being scattered. Light couldn't travel freely because it was constantly being scattered by the dense fog of hydrogen and helium atoms. Every time a photon tried to move, it would bump into an electron or an atomic nucleus, bouncing around endlessly in the thick cosmic haze. Imagine trying to see through a thick fog on Earth. No matter how hard you squint, you can't see more than a few feet ahead. That's what it was like in the early universe, except the fog was everywhere, stretching across the entire cosmos. But the universe was cooling, and as it did, something amazing happened. Over time, the temperature dropped enough for a dramatic transformation to take place, setting the stage for everything that would follow. The electrons that had been zipping around freely finally slowed down and combined with the hydrogen and helium nuclei to form neutral atoms. This was a turning point, as the universe began to change from a chaotic plasma to a more orderly state. This process, called recombination, transformed the universe from opaque to transparent. Suddenly, the fog lifted, and the universe opened up, allowing light to travel unimpeded for the very first time. Suddenly, light could travel freely across vast distances, carrying information from one end of the universe to the other. The cosmos was no longer hidden in darkness, but illuminated by the first light. This first light, a faint afterglow of the Big Bang, still exists today as a subtle glow that fills the entire universe, a silent witness to its earliest moments. We call it the cosmic microwave background radiation, and it provides us with a baby picture of the universe when it was just 380,000 years old, a precious snapshot that helps us understand how everything began. With the universe bathed in the faint afterglow of the Big Bang, a subtle, ghostly light stretched across the cosmos, a silent reminder of the universe's explosive birth. As the universe expanded and cooled, a period known as the Cosmic Dark Ages began, a time when the universe was shrouded in darkness, with no stars or galaxies to light up the vastness. It was a time of relative calm, but also one of immense potential, where the seeds of future brilliance were quietly sown in the silence. The universe was filled with vast, invisible clouds of hydrogen and helium gas, the simplest and most abundant elements drifting through the darkness. But no stars had yet formed to illuminate the darkness. No galaxies, no planets, just endless, silent night. Imagine a vast, dark ocean stretching out in all directions, its surface perfectly still, untouched by wind or wave, a cosmic sea waiting for the first spark of light. On this endless horizon there was only the faintest glimmer of light, a distant promise that something extraordinary was about to happen. This was the universe during the cosmic dark ages, a time of profound stillness and anticipation when the cosmos seemed to hold its breath. It was a time of waiting, as if the universe itself was poised for a transformation, longing for the first stars to ignite and break the silence. Within these dark, cold clouds, gravity was slowly but surely at work, gently pulling atoms together over unimaginable distances and timescales. Over millions of years, gravity pulled the hydrogen and helium atoms closer together, causing the gas to swirl and condense into denser regions. These regions grew into giant clumps of gas, the first building blocks of what would become stars, their mass and density increasing with every passing eon. Eventually, these clumps became so dense and hot that the conditions were just right for nuclear fusion to begin, marking the birth of the very first stars. With their ignition, the cosmic dark ages ended, and the universe was forever changed as the first stars blazed into existence, lighting up the darkness for the very first time. Deep within the cold, dark clouds of hydrogen and helium, gravity worked its magic. It pulled the gas together, squeezing it tighter and tighter. As the gas clumped together, it heated up, eventually reaching temperatures high enough to ignite nuclear fusion. This is the process where hydrogen atoms fuse together to form helium, releasing enormous amounts of energy in the process. And so, the first stars were born. Massive, brilliant giants, far larger and hotter than our own sun. These stars became cosmic furnaces, forging heavier elements like carbon, oxygen, and iron in their cores. These elements would later become the building blocks for planets, and ultimately, life itself. As more and more stars ignited, they began to cluster together, forming the first galaxies. These galaxies, vast collections of stars, gas, and dust, became the building blocks of the large-scale structure of the universe. Our own galaxy, the Milky Way, is a vast spiral galaxy containing hundreds of billions of stars. It's just one of billions of galaxies in the observable universe, each with its own unique history and population of stars and planets. Within the Milky Way, about 4.6 billion years ago, a giant cloud of gas and dust began to collapse under its own gravity. This cloud, located in one of the Milky Way's spiral arms, would eventually give birth to our solar system. As the cloud collapsed, it began to spin faster and faster, forming a flat disk of material. At the center of this disk, the sun ignited, becoming a bright young star. Around the sun, the remaining gas and dust began to clump together, forming planets, asteroids, and comets. Among the planets that formed in our solar system was Earth, the third planet from the sun. Early Earth was a very different place than it is today. It was a hot, volcanic world, constantly bombarded by asteroids and comets. Over millions of years, Earth began to cool down. Water vapor in the atmosphere condensed to form oceans, and the first continents began to emerge from the sea. The stage was set for the most remarkable event in Earth's history, the emergence of life. The exact details of how life began on Earth are still a mystery, but we know that life emerged relatively early in Earth's history, around 3.5 to 4 billion years ago. These first life forms were simple, single-celled organisms, but they possessed the remarkable ability to reproduce and evolve. Over billions of years, life on Earth evolved and diversified, from those first single-celled organisms to complex plants and animals. Dinosaurs roamed the planet for millions of years, until a cataclysmic event, the impact of a large asteroid, wiped out most of life on Earth about 66 million years ago. This mass extinction paved the way for the rise of mammals, including our own distant ancestors. Over millions of years, these early mammals evolved, adapted, and diversified, eventually giving rise to the human lineage. Humans, with their large brains and capacity for language and tool use, have come to dominate the planet. We've built cities, developed complex societies, and explored the world around us with insatiable curiosity. Our journey from the Big Bang to the present day is nothing short of extraordinary, a sweeping saga that spans billions of years and countless wonders. It is a testament to the power of the universe to create complexity, beauty, and life itself. From the smallest atom to the largest galaxy, the cosmos has woven a tapestry of existence, each thread connected in ways both subtle and profound. Everything in the cosmos is connected by a shared history, stretching back to the very first moments of time. All that we see and all that we are, bound together by a common set of physical laws that govern the dance of matter and energy. We've come a long way since those first single-celled organisms emerged in Earth's primordial oceans, evolving over eons into the rich diversity of life we see today. We've built telescopes that can peer back to the edge of time, allowing us to glimpse the universe as it once was, and to imagine what it might become. We are unraveling the mysteries of the Big Bang, piecing together the story of our cosmic origins, and we continue to explore the evolution of the universe, from the birth of stars to the formation of galaxies and beyond. As we look to the future, we stand at the threshold of new discoveries, with the potential to shape our destiny among the stars. We face both challenges and opportunities: climate change, technological leaps, and the quest to understand our place in the cosmos. The universe is a vast and mysterious place, filled with questions that inspire us to keep searching. There is still so much that we don't know, and so many secrets waiting to be uncovered. But one thing is certain: our curiosity and drive to explore will always push us forward. Our journey of discovery is far from over. In fact, it has only just begun. We are, after all, a product of the universe, shaped by its forces and inspired by its wonders. Its story is our story, and together we will continue to write the next chapter.